Okay, this says if sine of x plus pi over 4 equals 1/4, find the value of sine of 2x. Okay, so I know that sine of 2x, that has an identity, and almost always you'll use this identity if this is a type of problem you have. So I'm just going to write this is true. Okay, and then I also know that sine of an angle sum Okay, so like this can expand and give us using the angle sum formula. Okay, so there's some things we can evaluate. We know this is 1 over root 2. I know this is 1 over root 2. So I get sine of x times 1 over root 2. Let's just write that as sine of x over root 2 plus cosine of x times 1 over root 2. Again, let's just write it like that. Equals 1/4, and if you times both sides by root 2, this says that sine of x plus cosine of x is equal to root 2 over 4. So it seems like a dead end actually, because it's like I was kind of hoping to get out something like this, or even just sine times cosine. That doesn't seem to happen. However, if you square both sides, that will create this middle term that is actually identically this. And the other stuff, you'll see, produces another identity. So recall that sine of x plus cosine of x squared would be sine squared plus 2 times sine of x cosine of x plus cosine squared. Okay, again, maybe just if you're not sure what I did, I'm just saying this is obviously true. Okay, just expanding that little binomial. And this is supposed to equal the right side, which squared, which would be 2 over 16, or in other words, an eighth. But now look, we've got the thing I was referring to, right? That we need to know what that is. That's sine of 2x. So if I can isolate that, that'd be great. But sine squared plus cosine squared is equal to 1. So this is equal to, in the end, the expression 1 plus 2 sine of x cosine of x, and that equals an eighth. And that just means I can subtract 1 from both sides. An eighth minus 1, which is an eighth minus 8/8, which is negative 7/8. Okay, and again, of course, remember this is sine of 2x because we expanded it. And we get negative 7/8.